Okay, let's see how we turn a word problem into these. So this is also from the Test 4 review. It's the first problem on the page 4 of the Test 4 review, number 20. It's in eating together. In 2001, 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. In a recent poll, 403 of 1,122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. So that's then and now. Has the proportion of children under the age of 18 who eat dinner together 7 nights a week decreased? So let's focus on something. And our hypotheses are always first. It says use alpha equals 0.05 significance level. So what is our assumption? Our assumption is always either what we assume to be true or something that a previous study has shown. The thing the previous study has shown is that 38% of adults with children under 18 ate dinner together. So that's what we let P be. P equals 0.38. Now what is H1? Our alternative hypothesis that we're testing. We want to know if the proportion has decreased. So strictly speaking, we want P less than 0.38 because we're basically hedging our bets that it's less than that. I guess they probably didn't plan on Corona, but that's besides the point. So let's think about this. We are putting all our eggs in the less than basket. So when we want 0.05 significance level and we're putting it all in the less than basket, we're putting the 0.05 all over here. We are not splitting it above or below. We are just putting it below, which will be important for our critical value later. So step 2 is say what our alpha is. Our alpha is equal to 0.05. Now let's do the mid step again. What are the things that I need for the mid step? I need my personal value, p hat, and I get that by dividing my two numbers, 403 out of 1122. I'm going to round this to a few decimal places. So let's see, what is 403 over 1122? It's 0.35918. Now I know my P is 0.388, and I also need my standard deviation, right? That's the same thing from last time where we do the square root of that 0.38 times 1 minus 0.38. And remember, you always use your assumed true value divided by our total number of cases, 1122, our n. And when you put this into the calculator, you get 0.014491. Actually, we'll just go 0.1449. Okay, so there is my p hat and my standard deviation, which allows me to calculate my z-score. Now my z-score is equal to, remember it's p hat minus p divided by my standard deviation. So my p hat in this case is 0.35918 minus that 0.38 that I had at the very beginning divided by 0.01449. So let's put that in the calculator. 0.35918 minus 0.38 divided by 0.01449 is negative 1.44. Okay, so this is where you can differ between using the classical approach and the p-value approach. I will show both ways in the step 4, which is the way it differs. So we'll talk classical approach. And this is the only place they separate it, p-value. In the classical approach, I need to find a z-score for my alpha, which means I need to find the z-score where only 0.05 is to the left. So for alpha point, alpha equals 0.05, z, the probability is where the probability of being less than a certain number is 0.05. So I'm looking for the number on the inside, or the z-score that gives me 0.05. Now, if I look onto my z-score, it looks like this is negative 1.645. It's halfway between the negative 1.64 and the negative 1.65. Okay, so for the classical approach, I'm looking for, is it less than or greater than? So sometimes this is easier from a picture standpoint. If this is negative 1.645, negative 1.44 is actually here. Which means, is it in that lower 5%? No, because negative 1.44 is actually greater than negative 1.645. Which means we don't reject the null hypothesis. Now, how would this look in a p-value approach? We take our z-score. What's the probability that our x is less than negative 1.44? Well, let's look at the negative 1.44. And it looks like it's 0.0749. What that means is my chance of this happening was about 7.5%, but we only count it as unusual if it's less than 5%. So is 0.0749 is greater than 0.05. That means that it's more likely to occur than something unusual, which is again the same conclusion. Don't reject H0. Regardless of which way you do this, you should not be rejecting your null hypothesis if you're doing it right. So what is our conclusion? We would say there is not. So this was all step 4, by the way, and your conclusion is step 5. There is not sufficient evidence to conclude that the number of families eating dinner, number of families has decreased. We'll just say that. I hope these extra examples are at least somewhat helpful to you in understanding what's happening. If you need more help, let me know, and have a good rest of your weekend.